The hypothesis for the segment was the emission spectra of lambda max is determined by the observed color of the substance.
We'll start off by defining some terms.
Emission spectra is a tool to measure the photons emitted by a substance. It produces a graph of wavelength in nanometers against intensity, or the number of photons emitted at a given wavelength. A peak or peaks are produced which are representative of the solution. The example shown is of a red dye solution. The lambda max would be the wavelength of red light.
In order to determine if the hypothesis is correct, we first have to determine what the data would look like if it was correct.
This is a sketch of what the emission spectra would look like if the hypothesis was true, and we tested green dye, red dye, and a 1-to-1 green and red dye, which would be visibly orange. However, that is not the data we got.
The spectra for the red and green dye both present one lambda max, whereas the spectra for the orange or mix showed 2 peaks with local maxes. The wavelength of orange light was emitted at a very low intensity, whereas the 2 peaks of the spectra showed local maxes very close to the lambda maxes of red or green dye. This does not support the hypothesis.
To understand why this is, we compared the solutions. We noticed that the number of peaks corresponds to the number of types of dye molecules in the solution. This explains why no peak appeared at orange. No solution contained an orange dye molecule. All solutions only had red and or green dye, so only 2 peaks appeared.
Therefore, lambda max is most likely caused by molecular structure and the individual components of a solution, not the observed color. As shown, red, orange, and green dye have different molecular structures. These structures cause different wavelengths of light to be emitted and thus different lambda maxes.
Photons excite electrons on the particulate level, so the observable color will be the mix of all photons emitted by these interactions, and the individual colors produced may not be discernible.
An emission happens when an electron gets excited to a higher energy state, then falls back down to its ground state. The photon is the energy release as it returns to the lower state. Electron excitation works kind of like stretching. As you stretch farther away from your resting position, it gets harder to maintain and more favorable and comfortable to return to sitting upright.
The higher energy state is less stable than the ground state because it's further away from the nucleus, increasing the potential energy.
The energy produced by this is quantized and unique. It is affected by the distance the energy levels are from each other. This can be affected by things like number of protons, energy levels, or electron domains. This is why different dyes produce different wavelengths, and since it happens on the particulate level, observed color doesn't matter.